Hi students, in today's video I am going to explain hyperconjugation topic. This is under electronic effects. So as electronic effects I have uploaded two videos, inductive effect and its application oriented questions, previous year questions. I have uploaded two videos. Go through those two videos who is watching first time this one. Next electronic effect I am explaining hyperconjugation. Hyperconjugation also one of the most important topic in organic chemistry. Every organic chemistry stability explanation time, every organic chemistry molecules examples stability explanation time, we are using this concept, hyperconjugation. It plays important role. I have prepared notes also. Everyone make a note and prepare well for exam. Okay, let's begin hyperconjugation definition. Hyperconjugation is nothing but electronic effects means due to disturbances of sigma and pi electrons, right? So here sigma electrons, direct theory questions they are asking, because of pi electrons disturbance which effect will attain, which effect will come, and next one due to sigma electrons which effect, sigma electrons. So what is this? Inductive effect and hyperconjugation. That's why second topic I have selected this one. Complete delocalization of sigma electrons of sigma alpha H, alpha hydrogen. What is alpha hydrogen? What is alpha carbon? I am going to explain. Complete delocalization of sigma electrons of sigma C alpha H bond which is adjacent to sp2 carbon. Okay, sometimes they will ask sigma p orbital also. Both are same students. How? Why both are same? Why sigma p and sigma sp2 you are taking? I will show the points. It is also called it as no bond resonance. No bond resonance. There is no bond between carbon and hydrogen. Why it is no bond? Okay, I will show with best example. Afterwards, once again we will come back for the definition. Okay, now conditions. Towards competitive examination, you don't need to write definitions. We have to solve the questions, right? So conditions. What are the conditions? Given species must consist of sp2 carbon. Reaction intermediates time we have learned this point, students. Reaction intermediates video also I have uploaded. Free radicals, carbocation, carbanion. Free radicals, what is the hybridization? sp2. Carbocation, what is the hybridization? Yes, sp2. Right. So those species also, not only alkenes, most of the students know this one. Alkenes are sp2 hybridization, which is having double bond, definitely sp2 hybridization. Single bond sp3, triple bond sp. But double bond alkenes show sp2 hybridization. See condition 1, given species must consist of sp2 carbon and given species consist of alpha carbon. What is alpha carbon? I will show. With respect to sp2 carbon, alpha carbon must consist of hydrogens. Must consist of hydrogens. These two conditions must, students. Okay, what it all shows sp2 hybridization? I have written alkenes, carbocation, free radicals. These three, it shows sp2 hybridization. See, I am explaining one example here. In previous videos, I had explained carbocation, right? Carbocation stability order also. See, carbocation, you will take primary carbocation. CH3, CH2 plus, right? This is primary carbocation. Primary carbocation. This is actually unstable. All intermediates are unstable, but sometime it will exist due to somebody is giving electrons. He is actually electron deficient, right or not? So positive charge means he is not having sufficient electrons. He is deficient, but somebody is giving. Who is somebody? In the previous video also had explained what is this plus psi effect. Plus psi groups. Plus psi groups are electron releasing groups. They are giving electrons. They are giving electrons to this carbon such a way it is getting stability. It is stay sometime, it can stay sometime, it can stable. If no one is giving, then it is unstable, it destroyed. Okay, right. So here somebody is giving. Who is somebody? Electron releasing groups, those call it as alkyl groups, those we call it as plus I groups, right? How this plus I group is giving, how it is satisfying, I am going to show here. See, I am giving one more point, students. What is this hybridization? Carbocation is sp2 hybridization. Carbon, what is atomic number? 6. 1s2, 2s2, 2p2, right? And excited state electronic configuration, I am taking only outermost shell. Outermost shell only participate in bond formation, right? Only outermost shell participate. So better to take first ground state. Ground state means take 2 electrons here. Here how many electrons? Degenerate orbitals means filling first, right? Now excited state, the paired electron jumps into vacant orbital. Okay, excited state. Now students, listen carefully. Here 1 electron, here totally how many electrons? 3 electrons, right? So this is sp3 hybridization type. But what I said here, one important point to you, he lost electron. Plus charge is nothing but lost electron, right or not? This carbon lost electron. This electron lost. This electron lost. Now final state you can write now. This is 1 electron, and what about this one? Like this. Okay, he gone somewhere. So where he gone? Homolytic fission time I had explained. After breaking the bond, equally sharing, unequally sharing. Because of unequally sharing, he had given to hydrogen, or else he had given to some Cl, somebody. Okay, right, he lost electron. Now see, how many unpaired electrons here? 3 unpaired electrons with 3 hydrogens participate in bond formation. 3 hydrogen, each hydrogen has 1 electron, finally sp2 hybridization, 1s orbital, and how many orbitals? 2 p orbitals participating. Then we can call it as sp2 hybridization, right? And sp2 hybridization, it has vacant orbital. See, this is vacant orbital. Vacant orbital, what is the name? P orbital. Keep it in mind. These are all very important competitive questions. Okay. Now come back to this structure. Okay, this is condition. I have written this CH3. So he is giving electrons, is satisfying stability of carbocations. I am explaining here. Look into this. Carbon, it has 3 hydrogens. This carbon, it has 2 hydrogens and 1 positive charge I have written. And 1 empty vacant orbital. Just now I have shown how empty orbital we have got it. That empty orbital I have written here. Empty orbital I have written. Empty means he is deficient. Deficient means he is taking electrons, right? He is taking electrons. Who is giving? Between carbon and hydrogen bond is there. So that he is giving electrons. What is this electrons? We call it as, yes, sigma bond. Sigma bond means sigma electrons, right? The sigma electrons is transferred to here, vacant orbital. This electrons. Now, such a way, what is the output here? Look into this. Carbon, this hydrogen as it is, I have written. Okay. Now, here hydrogen. This hydrogen, between hydrogen and carbon bond is not there. Why? Because hydrogen given electrons, completely given electrons means positive charge. In inductive effect time also partial charges why we are getting, when we will get complete charges, detailed explanation I had given students. Now he is given here. So giving bond means, giving electrons means new bond develops. Already 1 bond is there. Now giving electrons means new bond develops. So finally you can write CH as it is. Now this carbon is happy. Now before it is deficient, right? Now you can calculate electrons around the carbon here, students. See, 1, 2, 3, 4. Satisfied. Before it is 3 bonds only. 3 bonds means deficient. What is the carbon number of bonds? Carbon valency 4. Around carbon 4 bonds is there. It is happy. If it is less bonds, deficient. It is excess bonds. What is this? We call it as excess electron rich. Okay, that is excess nucleophile. Then you can say this is electrophile. This is electrophile also, because he is taking electrons. Electrophile. All electrophiles are Lewis acids. These are all very important competitive points, students. Due to hyperconjugation, many topics depends. What is hyperconjugation if you don't have command? So definitely next step, not only next step, first step itself, organic chemistry feels very difficult. Try to understand what I am trying to say and make a note. And if you have any comments also, you can comment. Definitely we will teach, I will teach, we will discuss those points in our channel. Okay, now look into this. Clear point. Now this is between carbon and hydrogen. There is no bond. There is no bond. That is why we call it as no bond resonance. No bond resonance. That's it. So now go back to the case. Okay. Now one more point I am telling your students. One more point. Look into this. This is sp2 carbon, right? This is sp2 carbon. Is it visible? One second, let me use another color. Yes, this is sp2 carbon. Carbocation is sp2 carbon. sp2 carbon, adjacent carbon, very next, adjacent carbon, we call it as alpha carbon. We call it as alpha carbon. This alpha carbon having hydrogens, we call it as alpha hydrogens. Right? So, why alpha hydrogens is required to show hyperconjugation? This alpha hydrogens only giving electrons. Such a way he is getting stable. Such a way he is getting stable. Right? Not only this hydrogen, students. You can write this hydrogen also. You can write this hydrogen also. So, look into this hydrogen as it is. Now, he is giving. He will get positive charge. Again same story. Okay, not only this one, even third hydrogen, this one also give. So finally, how many alpha hydrogens is there? Those many hyperconjugation structures will come. Clear? It is very important point towards competitive. Easy tricks also we have, students, don't worry. Like this. Okay, theory examination means we have to explain. Now this hydrogen is giving, this hydrogen also giving, this hydrogen also giving, this hydrogen also giving. Finally, how many alpha hydrogens are there? Those many alphas, those many hyperconjugation structures we are getting. So hyperconjugation structures directly proportional to alpha hydrogens. If hyperconjugation structures are more, that is more stable. I will write the conclusions. Before going to that, I am showing the definition to you. Is it clear? See, complete delocalization of sigma electrons. From hydrogen we are getting electrons, no, sigma electrons to sigma alpha H, alpha hydrogens only giving bond which is adjacent to the sp2 carbon, or also we call it a sigma p orbital. Why p orbital? That empty orbital in the p orbital, right? So it is sigma electrons transfer to p orbital. So that is the definition, students. Clear? Not only carbocation, free radicals also sp2 hybridization, alkenes also sp2 hybridization. So we look into the different examples now. So most important short notes I am giving to you towards competitive examination. Within seconds you will get answer. What are the shortcuts I am giving here? Number of alpha hydrogens directly proportional to number of hyperconjugations. HC is nothing but hyperconjugation. Number of alpha hydrogens directly proportional to number of hyperconjugation. So number of, next point, number of hyperconjugation coefficients directly proportional to stability. Directly proportional to stability. That's it. That's it. See how easy it is. I am giving one best example. They'll ask one question. Question 1. It is very easy. 1 butene and 2 butene. Which is more stable? 1 butene and 2 butene. Which is more stable? So can you try this one, students? Can you try? First write down the structures. But means 4 carbons, right? 1, 2, 3, 4, right? 1 butene between 1 and 2 carbon. Between carbon 1 and 2 double bond is there. Remaining we have to fill with hydrogen. Hydrocarbons is nothing but only carbon and hydrogen, right? So this is what we call it as 1 butene. Don't write 2 butene. Between 1 and 2 carbons. Less number we can write. Next, can you write 2 butene, students? Again, but 4 carbons between 2 and 3. That's it. Remaining you can fill with hydrogens. That's all. Hydrogen. This is what we call it as 2 butane. Now they are asking which is more stable. Whenever stability type questions is there, we can apply hyperconjugation tricks, right? So now look into this, students. sp2 carbon. Everybody know what is sp2 carbon? All alkenes undergoes sp2 hybridization, right? This is sp2 carbon site, right? This is sp2 hybridization. Even this is also sp2 hybridization. First condition satisfied. What is the first condition I gave? It must have, the species must have sp2 carbon. Yes, first condition satisfied. And the next alpha carbon, which is sp3 hybridization. Is it sp3 hybridization or not? Check it. Yes, this is sp3 hybridization. This is the next condition. So next carbon we call it as, look into this, students, look into this. Suppose double bond is there. With respect to this double bond I am speaking. So here next carbon we call it as alpha carbon. Next carbon we call it as beta carbon. If still carbons is there, gamma, delta, like this it will come. Very next carbon we call it as alpha carbon. Is it alpha carbon sp3 hybridized? Yes, it is sp3 alkene. This is both are single bonds, sp3 hybridization. These two conditions must. Okay, sp2 carbon with respect to what is this next carbon alpha carbon. That call it as alpha carbon. It is must sp3 hybridization. Next one, alpha carbon is there, but alpha hydrogens also there or not? We have to check it. Yes, it has 2 alpha hydrogens. 2 alpha hydrogens. That's here we don't have carbons, leave it. Okay. Now come back to this one. Now what is this? sp2 carbon. What is sp2 carbon? Very next carbon, what we call it as? Alpha carbon. Is it sp3 or not? Yes, it is sp3. Is it sp3 or not? Yes, it is sp3. Right? This is what we call it as alpha carbon. Not only one side, students, other side also check it. But here other side there is no carbon, that's why we are not counted. But here other side also, very next carbon we call it as alpha carbon. It is sp3, right? So alpha carbon. How many alpha hydrogens here? 3. Here 3. Totally how many alpha hydrogens? 6 alpha hydrogens. What I said the trick here, number of alpha hydrogens directly proportional to number of hyperconjugations. So here finally what is the answer? 2 alpha hydrogens is nothing but 2 hyperconjugation structures. 6 alpha hydrogens is nothing but 6 hyperconjugations. So more hyperconjugations, number of hyperconjugations directly proportional to stability. Which is more stable? Yes, this guy more stable. Books we have taken alpha plus 1 also, students. Suppose 2 alpha carbons means 2 plus 1, totally 3 hyperconjugation structures we are writing. And suppose 6 is there, 6 plus 1 totally 7. Here also one increasing, here also one increasing. You can take like normal method or else alpha plus 1 also, both will come same answer. Okay, both will come same answer. This is old textbooks they had given, but nowadays we are following this trend only. Just to calculate alpha hydrogens, that is nothing but hyperconjugations. Hyperconjugation structures is more, that is more stable. Is it clear? It is one of the important question. Now I am giving another question, students. Look into this. Hyperconjugation negative is there and electron releasing group. Some different questions I made, students. All I will upload. Okay. Reverse of hyperconjugation, normal hyperconjugation. Next video also I will explain. First some questions we will discuss here. Applications. Immediately if you start working different questions, you will get good command organic chemistry, first one. So here stability of alkenes. Stability of alkenes they are asking. Only 10 minutes video, 12 minutes video if I will make, you may not understand. I will go fast explanation. Fast explanation, you may not understand anything. I am explaining slowly. Try to understand, students, without skipping all examples you can work out. Then you will get good command. So write down, this is CH2 double bond CH2. What is this? We call it as ethene. Okay, ethene. How many alpha hydrogens you can write? And hyperconjugations. And the next one, hyperconjugations also you can write. Then stability you can explain. What is this? Total hyperconjugations is more. That is more stable. No? That is more stable. Right? Write all the points. Now next example. Next example, propene. Next example, butane. Just now we have taken, again 2 butane they will ask, 1 butane they will ask. Both I had explained. Just 2 butane I am taking. Butane. Next one. They will give the branches also. No issue. Big structures sometimes. Answer is within seconds you will get answer. Okay. Now next one more. That's all. Now try to understand what is this ethene. sp2 carbon. This is also sp2 carbon. Both are sp2 carbon. First condition satisfied. First condition satisfied. But what about the next condition? It must have alpha carbon. Second condition. But where is alpha carbon? No alpha carbon. So alpha hydrogens is 0. Hyperconjugations is 0. Then it is what? Less stable. Less stable. That's it. Okay, now here alpha hydrogens. Can you count alpha hydrogens? This is sp2 carbon. Here it's not there. Here alpha carbon is there. Alpha carbon, how many hydrogens? Alpha carbon, 3 alpha hydrogens. That only you can write. 3 alpha hydrogens, 3 hyperconjugation structures. I said to you one more point, students. You can take it alpha plus 1 also, or directly also you can take it. No problem. Now this one. Yes, this is sp2 carbon. This is sp2 carbon. This is sp3. This is sp3. How many sp3 hybridized carbons? 2. How many alpha hydrogens? 6 alpha hydrogens. 6 alpha hydrogens. 6 hyperconjugations. Now this one. Now this is what, students? sp2. This is what? Now very next, this is sp3. This is also very next, sp3. This is also very next, sp3. Understood my point? Now totally how many alpha carbons? 3 alpha carbons. How many hydrogens? 3 plus 3, 6. 6 plus 3, 9 hyperconjugations. 9 alpha hydrogens. 9 alpha hydrogens means 9 hyperconjugation structures. You can write here 9 alpha hydrogens, 9 hyperconjugation structures. Clear? Now this is your active site, right? Now sp2 hybridized, sp2 hybridized. So what is this? sp2 hybridization, sp2 hybridization. This is This is sp3. This is sp3. This is also sp3. See how many? All are alpha carbon. This is alpha carbon, alpha carbon, alpha. Very next. So alpha carbon. Totally how many alpha carbons? 1, 2, 3, 4. 4 alpha carbons. How many hydrogens? 3 plus 3, 6. 6 plus 3, 9. 9 plus 3, 12. 12 alpha hydrogens. That means 12 hyperconjugation structures. Now write down stability order. Stability order. So sometimes they will ask questions. Among the following, in which case hyperconjugation structures not possible? See, hyperconjugation structures not possible in case of ethene. Hyperconjugation structures not possible. These are all frequently asking questions in competitive. I have made all this. Please make a note. Hyperconjugation structures not possible due to no alpha carbon. No alpha carbon. Both the conditions satisfied, then only. Clear? That's it. Now take it as structure 1. This is structure 1. This is structure 2. And this is structure 3. And structure 4. This is structure 5. So can you give what is the order? What is the order, students? Yes. So 5 greater than, 4 greater than, 3 greater than, 2 greater than 1. Which is least stable? 1 is least stable. Which is the more stable? Only 2 points they will ask sometimes. Sometimes they will ask ascending order. Sometimes they will ask descending order. So all. So finally I have covered more questions, hyperconjugations content, and the next video hyperconjugations, reverse hyperconjugation and some important questions also I am going to explain. Thank you students. Thanks for watching.